Hi, today I will be presenting Physics 2211 Lab 2 over projectile motion. For a brief introduction about what the purpose of the lab was and how we executed the experiment, um, basically the purpose of the lab was to compare the position graph to the time graph of a real-world and experimental projectile motion example, which was done by computationally simulating projectile motion with drag and without drag. For the setup, we filmed a video and uploaded it to Tracker, which extracted positional and time data, and then we compared the observations with our predictions from a computational model based on Newton's second law. Which Newton's second law basically relates the net interaction between system and surroundings to the observed motion of the system, meaning that the net force acting on the system is equal to change in momentum over time. Here we have the F net formula, which is Newton's second law. But other key equations for this experiment were the position update formula, which is final position equals initial position plus the average O times change in time. Then velocity update formula, which is final velocity equals initial velocity plus F net over m times change in time. And then we also have the force of gravity and drag formula. For the experimental setup, it was just a paper ball, which we had the calculated mass for, and we threw it in a diagonal motion. There was supposed to be a picture right here to the left of it. And here in the middle, we essentially have the information extracted by Tracker, the position, the initial position, and it's not shown. The picture is not showing up on here, but the final 3 points for the final time was 1.333, with the final x position being 1.17 and the final y position being 0.378.
Did you sign it?
The experimental details slash code, basically for the overall for an overview of the procedure, we used the initial code that was given to us in the lab instructions and modified it using our calculated delta t initial position and time. For the code details, it's not showing up on here, but we essentially edited the delta t to match our change in time, and the middle picture showed how we edited the arrow scale, the how we applied the Newton's second law to update velocity and position, and how we included the calculation for net force. And this picture to the left is the result it gave us. And here are the results of the glow script. In the middle, the two pictures that are missing, one went with very much like the picture on the right. Here you can more see like the change in the x positions compared to the change in y positions for the experimental data, and then the computational data using drag and no drag. Here is another one of those. And potential error during our lab was that in the coding portion there was a confusion over what the number four drag should be. So the number we inputted may have not actually been the accurate one. However, after discussing with the TAs, we were told that any effect that it would have would be minuscule on the results. And for the what if questions, if the paper ball had been thrown directly up, it would take longer than the ball being thrown how we did in the video, because it had more drag and having to go up and then down. Thank you.